it's being difficult trying to teach, and so you guys are having side conversations. So please leave it at a minimum until I am done teaching. All right, 10-4 standard deviation. So here's the definition of standard deviation. So standard deviation is a measure of spread or variability. It indicates by how much the values in a data set deviate from the mean. So remember, mean is the average. It is the square root of the variance. The variance is the average of the square deviations from the mean. So when data are normally distributed in a bell curve, the mean and standard deviations describe the data set completely. So you have the mean, you have the bell curve. Standard deviation to the left is -1. 2 standard deviations is -2, and then -3 standard deviations is to the left 3. This just means like how far away of how spread out your data is. Ideally, in statistics, you want to have your data as close to the mean as possible, but obviously that's not always the case. So, because depending on your data, it can either be between 1 standard deviation or 2. So ideally, you always want to have it between 1, so 1 on the left, 1 on the right. 2 is okay, but usually anything higher, you kind of have to worry about like your data. You have to question it. So that's pretty much all it really means. And the percentages means how much of your data is between the standard deviation. So this is, I believe this is 64, no, like 68.2%. So ideally, this is where you want majority of your data to be. So for number 1, on a test score are normally distributed by the mean of 150 and a standard deviation of 30. What is the score that is 2.5 standard deviations above the mean? So when anytime you want to have a question regarding standard deviation, the first thing you want to do is just draw the bell curve. The middle of the bell curve is your mean. Now pretty much the next step is for you to find the standard deviation on the left and standard deviation on the right. Now it says your standard deviation is 30, so that means your value of 30. So 1 standard deviation to the right will be 180. So that's 1 standard deviation on the right. So that's why you have the +1. The +1 means it's to the right of the mean. To the left of the mean, so -1 would be 150. Oh, you're right, not 120. 120, thank you. And then you keep going. So 2 standard deviations would be 210.
And Mr. Marcos,
What's up?
would 2.5 variations be 225?
That is correct. Yes. But before we get to that, we want to make sure we write all of them down first. So then 2 standard deviations to the left. So we're going to put the -2 because that's what the -2 means. So that would be 90. And then you only go up to 3. So the next one would be 210 would be 240. And then 1 standard deviation is 60. So to determine what 2.5 standard deviation is to the right, well, if 1 regular standard deviation is 30, I only have to go by 1/2. So that means 210 plus 215 would be exactly as Nat suggested or answered. It would be 220. No, 225? Yeah. So that is 2.5 standard deviations. What? On the left-hand side? No, but it's good practice. So then 2.5 standard deviations would be 225. So then right here, it's going to be 225. That would be your answer. So you just have to go halfway between 2 and 3rd standard deviation. Now the key word for this, you gotta make sure you gotta read, is above the mean. That means you're going to the right of the standard deviation. So you have to be very careful because if it said below the standard deviation, that means you have to find the number on the left-hand side of the mean. Any questions so far? All right, let's do the next one. So number 2, the scores on a test are normally distributed with a mean of 40. The standard deviation is 8. What is 1.5 standard deviations above the mean? So same thing, draw the bell curve. Draw the mean. Now, luckily, it's asking us what is standard deviation above, so we're gonna go to the right. So 1 standard deviation to the right is 48, right? Because 1 standard deviation is 8. Now it wants to go 1/2. So that means if I want to go half a standard deviation, what would it be then? 52. So you're adding 4. Because another whole standard deviation would be 56. Very good. So 56. So that's the 2 standard deviations, but we're only going half. So between 48 and 56 is 52. Because it's asking us for 1.5 standard deviation. So we went 1/2. Sorry, we went 1, and then we're going half between 1 and 2. So we know that's 1 standard deviation. It's 8. So then half of that is 4. So that means we're adding 4 to the first standard deviation. So the answer would be 52. Does anyone have any questions? So numbers 1 and 2, they're not too bad. They're not too difficult. It's the 3 and 4 there. Might take you a little bit of time to do. Math 1. Okay, let's do the nitty-gritty one. So now find the mean, the variance, and standard deviation of my data set. We have 10, 16, 10, 15, and 14. Now, when you do these, ideally, it's always best to go from least to greatest, but we don't necessarily have to, but it's recommended, but we'll skip it. So the mean, does anyone know how to find the mean? I said it yesterday. Very good. How many numbers do we have? Is it 5? Make sure, because if you don't count it correctly, you're gonna have to start all over again. And trust me, you do not want to do these all over again. So it is indeed 5. So if we add them all together, 10 plus 16 plus 10 plus 15 plus 14, we will get a value of 75. Someone double check. Is that correct? All right. So I got 65 too. Shoshana got 65. Anyone else? Double check, please. Double check. It's not here. Thank you. Yep. So you guys get 65? 65, yes. Okay, double check because I don't want to do this all over again. 65 divided by 5, it is 13. Okay, so we found the mean. That's part 1, is finding the mean. Now, here's the thing. In math, we kind of don't like to write a lot, so we gave it a symbol. X with the line on top. In mathematics, that means mean or average. So on the test, if I ask you for the X on the bottom or X and then the line on top, that means I want you to find the mean. We pretty much gave words to everything. So we just started just keep making up symbols and just gave it a definition. So that is the mean. Now you're going to find the variance. And this is what you're going to do to find the variance. You're going to take each of your numbers. So create a table. To find the variance, you're going to create a table. You're going to put all their numbers. 10, 16, 10, 15, and 14. Now, the first step to find the variance, you're going to take every number and you're going to subtract it from the mean. So that means I'm going to take 10 minus 13. 16 minus 13, 10 minus 13, 15 minus 13, and 14 minus 13. 10 minus 13, -3. 16 minus 13, 3. 10 minus 13, -3. 15 minus 13, 2. And then 14 minus 13, which I got 1. Once you subtract each of the numbers by the mean, you're gonna double it. You're gonna square it. So x minus x with the dot, well, sorry, with the line on top, squared. So that means I'm gonna subtract them and then I'm gonna square them. So -3 squared. Oops. Nope. It is 9.
When you square something, you multiply by.
Right. So -3 times -3. +9, +9, +9, 4, and then 1. Okay. Your next step after you square it, you're gonna have to find the sum, adding them all together. So the sum of your numbers divided by the mean squared. Yep, always squared. This is called the sigma.
What?
It is called a sigma. In mathematics, this means sum.
Sideways W.
It's a sideways W. It's called a sigma. But in mathematics, we give it the definition of a summation. Summation. So the sigma, the sigma symbol is summation.
How do we think about it?
So if you guys ever heard the word sigma, they're literally just telling you to add because that's what it actually means in mathematics. Okay, so you're gonna add all the numbers. And then so it's gonna be 9 plus 9 plus 9 plus 4 plus 1. That will give you a value of 32. Because you're finding the standard deviation by hand.
Do I have to do this on the test?
Yes.
Oh, no.
You
Are you multiplying the W by the?
no, it just means sum. It means you're adding all the numbers. It's just a symbol. Yes, the symbol tells you to add them all together. Does that make sense? Okay. So once you find the summation, you are gonna take that number, divide by the how many there are. You're pretty much taking the average.
This is way too much. This means it's really. Yeah, this is.
So you're gonna take the number 32 and divide it by 5. Huh? Yeah.
There's no like.
No, unfortunately not.
There is something like just doing it.
What is this website on you?
It's an N. What are you guys talking about?
Oh. What is that?
How many numbers there are? It's the number of data. So 32 divided by 5. And that's how many numbers there are. Yes.
Yeah.
6.4.
6.4. This number right here is your variance. So yes. Oh, my bad. 6.5. My apologies. 6.5. I'm sorry. 6.5. Okay, this right here is your variance. So theta is equal to the summation of x minus x bar squared divided by m. This is your variance.
Bro, let's. On people rage.
Daniel, all this is for.
Yeah. 6.
So we're finding the variance.
Why does all change? Why are you putting 6.5 here?
Hey, that is called a theta. So theta is just no, that's what it is. Theta.
They don't even beta. Why don't they?
Theta.
That's what I call beta.
Yes, it's right there. It's the theta. It's the it's the circle with the little with the little haircut. Theta. THETA. TH. Theta.
Beta?
No, beta has a whole different variable. Potato. Yes, you have to put the old tail. No, you either put it a tail. There's a lot of ways people use it. You could either do it that way or you could do it this way with the line going straight through it. Because that's the variance. The variance is this squared.
Okay, so. Called a theta?
Yes, it's called a theta.
Why you making up?
I'm not making up symbols. They are. This is just how you solve the standard deviation by hand. Oh, trust me, if you guys ever go to college with math, man, you guys learn like pretty much the whole alphabet. So it's it's a lot, but don't worry, it'll all share this same common. No,
Oh, that you don't.
no.
I do so.
Okay, so all right. Shh. Okay, so we got the variance. Oh, and the mean. We found the mean to be, what was the mean? 13. So that's where it goes right here. Sorry. So for your homework, that's where it's gonna go, 13. And then your variance is 6.5. So it's pretty much you taking the mean, subtracting from all the numbers, squaring it, adding them all together, and then finding the average. That is the variance, 6.5. Now, the last part's asking you is to find the standard deviation, so theta. So in this case, theta, you take your variance and you square root it. So my theta is equal to the square root of 6.5. You should have it in your calculator. It is 2.
Wait, could you use calculators?
No. Oh, yes, 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 you can.
What are we? For the standard.
Deviation, yes. What?
Wait,
Okay, that's.
Yeah.
That's like the very thing square root of.
Although Leo has a good question. I totally forgot that you guys probably don't know how to actually plug in square roots. So if you have your calculator, where is it? Where is it? Okay. So you're just gonna do this one right here, Leo. The square root is right here. So we're at square root. You don't need the O. It's just like X, so you don't need it. So you'll get 2.549, but it says rounded to the nearest tenth. So it's gonna be 2.55. Nah. All right. Shh. Focus. I need you guys to focus. Coco, focus. Thank you. I know. I know. Okay, so we found the standard deviation. For number 4, we're just gonna do it one more time, but this case we have more numbers. All right, first things first. Shh. So number 4, the diastolic blood pressure of 10 people body undertake a supervised diet program are listed on the right. Find the mean and standard deviation of the blood pressure observation. So we're gonna take all these numbers. So 134 plus 127 plus 131 plus 141 plus 134 plus 137 plus 146 plus 148 plus 142 plus 140. Divide that all by 2, 4, 6, 8, 10. There's 10. And this will give us our mean. So bar X. So be very careful. I need you guys to double check and do it with me. So I know we did it right, because otherwise we're gonna start from the very beginning. So 134. Let's see, 134 plus 127 plus 131 plus 141 plus
1,000.
Did you divide it by 10? Did you guys all divide it by 10? Did you guys get 138? No, after you divide it by 10.
130.
All right, so did everyone get that? Because that's the first step.
138 divided by,
No,
Add all the numbers.
and you divided by 10, you got 138, 'cause I thought she said 1,308.
yeah, but then you divided it by 10 and you get 138. So numbers 3 and 4 are gonna take you the longest. Just the only thing I can tell you is just please be careful, because if you mess up, you're gonna have to just do it all over again. And it's honestly, it's one of those problems you don't want to do more than once. So be very careful. All right, the next part is, remember, we're gonna take the number and we're gonna subtract it from each of the values that we have to find the variance, to find the standard deviation. So 134, 127, 131, 141, 134, 137, 134, 137, 146, 148, 142, 140. If you guys ever go to college, do not take a stats class ever. You're gonna be miserable. Very, very. Don't take stats in college. Take calculus instead. Calculus is so much easier. Calculus. Yeah.
138.
Yes, very good. So now we're gonna take each of those numbers. Shh. So I need you guys to make sure you pay attention, because we need to make sure we do this right. So we're gonna take all those numbers and we're gonna divide it. So sorry, divide it. Subtract it from the mean, which is 138. So 134 minus 138, 127 minus 138. And please do it with me, so that way I know we're all doing it together and we are doing it correctly, because I do not want to get this wrong. 137 minus, oops, 38, 146 minus 138, 148 minus 138, 142 minus 138, 140 minus 138. All right, let's see. 134 minus 138, -4. 11. I want to say that's a -11. Yes. -7. 3. -4. -1. 8. 10. No, +10. So 10. -3. Right, 142 minus, yeah, -3, and then 140 minus 138, +2. So make sure you double check, make sure you guys getting the same answers that I am. Do not just write out what I'm doing, because we gotta do this correctly. 134 minus 138. Yeah. Oh, you're right. See, thank you, thank you. Okay, this is actually +4. Okay, yeah, thank you, thank you. So everyone double check, double check. Not yet, we have to square it. You just multiply it by itself, remember?
Mr. Marcos?
Yeah.
I believe 127 minus 138, -11.
That's what he wrote.
Yeah, that's what you put.
That was because I.
That's what you put.
Yeah, it's -11.
Oh, I see it negative 11.
Uh,
I can't see. Maybe that's wrong.
all right, so is everyone good? Does everyone get it? Because we should all gone the same. Okay, so now the next part is to square it. So we're gonna take those numbers and we're gonna square them. So -4 squared is 16. -11 squared is 121. -7 squared is 49. 3 squared is 9. -4 squared is 16. -1 squared is +1. 8 squared is 64. 10 squared is 100. 4 squared is 16. 2 squared is 4. Okay. All right, I'll give you guys a minute to write it all down. That's just how you do it by hand. And honestly, there is a shortcut, and that's the computer. You can actually plug in data and then have you spit out the standard deviation. But we're mathematicians. We got to do this stuff by hand first. If you're in this class, I consider you to be a mathematician. If you're in the other class, then maybe not. But if you're in this class, I consider for you to be a mathematician. And then if you're in this class too, then I expect you to know how to do it too. If you're in the other class, maybe not, but you're in this class. So the other class is Math 1A and Transitional Math. They're still in chapter 2, I think, or chapter 3. But we're going more faster.
Is Brian in the traditional maths?
Yeah.
Oh,
No, I think Brian's in Math 1A, I think. Oh, is he? Oh, okay then. I'm not really sure with the other students. Yeah.
Yeah,
All right.
we're going way faster, so you don't need as much time to learn it, so technically works. You can go, I see that, I just.
I told you guys from the very beginning we want to stay this way. All right, so the summation of our values is going to. All right, so then we're gonna add them all together. 16 plus 21 plus 49 plus 9. I'm running out of space. Plus 16 plus 1 plus 64 plus 100. Oops. It's just you just have to all follow steps, and it's just honestly tedious. Let me know what you guys got when you add them all together. 16 plus 121. Because all right, did you guys all get 396 when you added them all together? Yeah? Okay, cool. I want to make sure we all got the same answers. Because either I can make a mistake on the calculator, or you can make a mistake on the calculator. So you just it's better if we do it all together. No, we are, but we're not there yet. So after you find the summation, you're gonna take that number. And we're just gonna divide it by how many are. So it's pretty much taking the average. So 396 divided by 10. So 39.6.
Wait, it's 396?
Yeah, 396. Or which one? The sum? The sum is 396. Yes, the average of that is 39.6 because we're dividing by how many numbers there are.
So the standard.
No, the variance is 39.6. So we're still not done yet. So yeah, it's a little O. That's a delta. Because we need the variance to solve for the standard deviation. Okay, so that means theta squared is the variant. Oh, sorry, the variance is the sigma of the summation of x minus x prime squared divided by n, which is 39.6. So this is variance.
So the whole thing is 31.
The O thing squared is 39.6. The O, which is the standard deviation. So the thing is, we need the variance to find the standard deviation. We're gonna take the number and we're gonna square root it. So that is the standard deviation. So if you're wondering why we're doing the wiggly tail squared is because we take the square root of the number that we find that is equal to that number, and that gives us the standard deviation. Right. The square root. Square root.
Is that
That is 6.29.
same?
The square root.
Square root of it is the same.
Yes, that is correct. The mean is 138. Whoever said 138, that's the mean, by the way. And when you take the square root of 30, 130. That's the first number. That's the mean. Yeah, this is the first number that we divided by 10. We took all the numbers, added them together. And then I kind of ran out of space, so I had to put it up there. Yes, the O thingy squared. So that means my standard deviation is 6.29. That is the answer. What? Yes, this is statistics.
How does this become a statistic?
Statistically. All right, shh. Hold on. I'll help you right now. Give me a second. Right here, when we found the variance, we did 32 divided by 5 to get 6.5. That is not correct. 32.5, oh sorry, 32 divided by 5 is actually 6.4, not 6.5. This is the correct variance. Yeah. So do be careful because that ends up changing our standard deviation.
What's that square? I'm thinking of that. Our standard deviation is then, oh yeah, what's the standard deviation? 2.54?
Well, let's see. It was 6.4 squared.
2.65.
So let's see. The square root of 6.4 is 2.53. So you have to be very, very careful because you have to be as accurate as possible because otherwise it will not read it correctly. Yeah, so it's 2.53. That is the correct standard deviation and the variance for number 3. So do be careful with the math part because if you don't do it correctly, it's gonna tell you it's wrong. So make sure you put it in the calculator. But other than that, just be careful.